Work, energy, and power. How are these concepts related? Let's find out in this video. What is work? Okay, Rihanna might have defined work in her song, but in physics, work is actually has a very specific meaning. Okay, so work represents a measurable change in a system caused by a force. Okay, as you can see in the picture in our image, so there is a man pushing the wall. Okay, so a pushing force does no work if the wall does not move at all. Okay, but a pushing force does work if the wall moves even a little. Okay, so even if you try pushing a wall, even if you feel tired after pushing it, if the wall doesn't move, then there's no work done at all. Okay, therefore, work measures the amount of change produced by a force when it is applied on a body. The change may occur in the velocity of the body, in its position, in its size, or shape. If you push a box with a force of 1 Newton for a distance of 1 meter, you have actually performed 1 joule of work. Okay, so our unit for work is joules, or you could also use Newton meter. Okay, by definition, the work done by a net force acting on a body is equal to the product of the net force and the distance through which the force acts, provided that force and distance are in the same direction or they are parallel. Okay, so mathematically speaking, work is equal to force multiplied to your distance. Okay, so the units for work is joules, for your force it is newtons, and then for distance it would be meter. So let's try solving one problem related to work where force is parallel to the distance. So here is our problem. A 100 Newton force is applied to move an object in a horizontal distance of 5 meters at constant speed, neglecting friction. So let's calculate the work done on the object. So first, pause this video and try solving on your own, and then go back to the video once you're done. Okay? So let's try solving now. Work is equal to force multiplied to distance. Okay, so that is our formula. And then we substitute the value. So our force would be your 100 newtons and the distance would be 5 meters. Then multiplying these. So we have work as 500 newton meters or 500 joules. So this is the total work done on our object. Okay. So if force and distance are not parallel but are degrees apart, then we calculate work through this formula. Okay, so work is equal to force multiplied to distance multiplied to cosine theta, which will represent our angle. Okay, so our unit for work is again joules. For force it's newton, for your distance it's meter, and then your theta would represent your angle. Okay, so our example here is your a man pulling a cart at an angle. Okay, so let's try solving one problem related to this. So our problem goes, how much work is done when a mother pushes a baby pram at a distance of 54.4 meters using a force of 62 newtons at an angle of 30 degrees to the horizontal? Okay, so again, pause the video, try solving, and then let's solve together afterwards. Now, in our problem, work is done by the horizontal component force. So, we substitute now our values in our formula. Work is equal to force multiplied to distance multiplied to cosine theta. So, our force is 62 newtons as mentioned in the problem. The distance is 54.4 meters and our angle is 30 degrees. Okay? So, when doing calculations like this, you input everything in the calculator at once, okay, not one by one, to avoid arriving at different significant figures, okay? Now, total work done is 2,920.9 joules, or you may still use our Newton meter. Okay? Now, we could also observe work done against gravity. Okay, so when a body is raised vertically with a constant velocity, the force that must be exerted should be equal to the weight and the distance traveled, which corresponds to the height when it is raised. Okay, so our formula for work when done against gravity is W, or work, is equal to mgh, where m is your mass, which we would be using the unit kilogram. Then we have your g, or your gravity constant, and then you have h for the height of the object raised. Okay, the gravity, we would be using the value 9.8 meters per second squared for your gravity constant. Okay, so in case you see other units, just convert them to meters per second squared. Okay. So I want you to solve this problem about work done against gravity. So a crane lifts a steel beam with a mass of 1,500 kilograms. So calculate how much work is done against gravity if the beam is lifted 50 meters in the air. Okay? So pause the video, copy the problem, and then I'll show you the solution later. Okay? So now let's have another concept related to work. Let's have power. Okay, so what is power? Power is actually the rate of doing work, or it is the amount of work done divided by the time it takes to do work. Okay, so mathematically, we could express power as P is equal to W over T, or W divided by D, where power is expressed in watts. Your work or change in work or energy is expressed in joules, and your time or changes in time is expressed in seconds. Okay? So power can also be expressed in terms of velocity. So from the definition of work, it could be expressed as a multiply or as a multiple of force and its velocity if the velocity and force are both vectors in the same direction. Okay, so you have here another formula. We simply multiply force multiply to velocity. So our unit for your force is newtons, and for your velocity is meters per second. Okay, now the unit for power is called a watt, and another unit more familiar to you is horsepower. Okay, so you could usually read horsepower in some of our appliances. Okay, so 1 horsepower is actually equal to 746 watts, so you could use that as a conversion unit for expressing your power. Okay, so power in human technology is usually observed in the different machines we use every day. So here are some examples of the common appliances and its power used. So for example, your refrigerator, you have 700 watts. For your washing machines, 400 watts, and others. Okay, so machines are actually designed to use the appropriate amount of power to create enough force to do the work they are designed to do. Okay, so if you're going to compare now your refrigerator to the television, so the refrigerator would obviously require more power so that it could cool our food, or it could preserve the food that we put in the refrigerator, while the television would just be flashing lights or flashing shows, so a minimal amount of power is needed. Okay, now let's go to the last concept that we would be discussing in this video. I hope you still have your energy. Okay, so because this is our last. Okay, now energy is actually the ability to make things change. Okay, so a system that has energy simply has the ability to do work. Okay, so our unit for energy is the same as work because energy is transferred during the action of work. Okay, now there are different forms and types of energy, but we would be highlighting two in this video. You have your kinetic and potential energy. Okay, so the different forms of energy, you have your mechanical, radiant, nuclear, electrical. You also have your chemical, gravitational, thermal, and others. Okay. Now let's go to the first type that we would be discussing today. We have your potential energy. Okay? So potential energy is also known as your energy at rest. Okay? Mathematically speaking, this could be expressed or calculated as mass multiplied to gravity and height. Okay, so this is similar to your work done against gravity. Okay, so the unit for your potential energy is joules. For your mass, again, we will say be using kilograms. For your gravity, or the acceleration of gravity, we would be using the constant 9.8 meters per second squared. And for your height, we would be using the unit meters. Okay, now let's solve one problem related to potential energy. Let's use this formula. So a cart with a mass of 102 kilograms is pushed up a ramp. Okay, so the top of the ramp is 4 meters higher than the bottom. So how much potential energy is gained by the cart? Okay, so you may pause the video to solve on your own first before you proceed. Then you play the video once you're done. Okay, now in solving this, so we write our formula and then we get our values. So our mass is 102 kilograms and our gravity constant is 9.8 newtons per kilogram. So we are using another unit instead of the meters per second, but anyway, that's the same. And then we have your height, which is 4 meters. Okay, now multiplying all these, our potential energy is 3,998 joules. Okay. Now, another type of energy is your kinetic energy or the energy in motion. Okay, so the kinetic energy of a moving object depends on two things, the mass and the speed. So, kinetic energy is actually proportional to your mass. So, mathematically, kinetic energy increases as the square of speed. If the speed of an object doubles, its kinetic energy increases 4 times. Okay? Now, the formula for kinetic energy is expressed as Ke is equal to 1/2 multiplied to your mass and velocity squared. Okay? So, the unit for kinetic energy is joules. For your mass, we will be using kilograms. And for your velocity, we have meters per second. Okay? Now, we are going to square the velocity. Okay? Hindi siya magiging meters per second squared. That would be the unit for acceleration. Okay? Just clarification. So that's just a clarification, okay? Now, let's solve one problem in calculating the kinetic energy of a moving car, okay? So, a car with a mass of 1,300 kilograms is going straight ahead at the speed of 30 meters per second. Now, the brakes can supply a force of 9,500 newtons. Calculate the kinetic energy of the car. So, the formula is already provided. K is equal to 1/2 mass multiplied to velocity squared. Okay? Now, let's substitute our values. So, we simply input now our mass, which is 1,300 kilograms, and our velocity, which is 30 meters per second. Okay? So, again, you do your computations in your calculator in one equation to arrive now at your answer, which should be 585,000 joules. Okay? Now, we have just discussed two types of energy, or kinetic and potential energy. Okay? Now, energy cannot be created or destroyed according to the law of conservation of energy. Okay? So, your energy could just be transformed to one form to another. Let's say, your potential energy could be transformed into kinetic energy and to other forms of energy. Okay, so as energy takes different forms and changes things by doing work, nature keeps perfect track of the total. Okay, so again, no new energy is created and no existing energy is destroyed. Okay, so I hope you learned something from our brief discussion of work, power, and energy. Okay, but before we end the video, let's go back to our problem about work done against gravity. So, our solution now, so we simply substitute our values for work. So our mass is 1,500 kilograms. Our gravity constant is 9.8 newtons per kilogram. And our height is 50 meters. So you should arrive at the answer 735,000 joules. Okay? So that would be all for work, energy, and power. I hope you learned something. So if you have questions, feel free to comment them down below and just wait for my response. Okay? I'll see you in the next video. Bye!